Welcome to Mathematical Modeling and Reasoning. We're going to start off here with Lesson 1-1, Rates and Proportions. So first off, we have a definition here. A rate is the ratio, also known as a fraction, of two quantities. A unit rate is a rate with a denominator of 1. So what a rate may be, we may say for every 2 miles we use half a gallon of gas. But a unit rate is going to tell us, for example, for denominator 1, it's going to tell us how many miles we can go on a single gallon of gas. A proportion equation is an equation that shows the equivalence of two rates or ratios. So we can have proportions, and what we can do with our rates is we can set these proportions to solve for an unknown quantity. Maybe we know how many, for each hour, and maybe we want to find out, well, how many they're going to be in 5 hours, stuff like that. We have an example here. Your car can drive 300 miles on a tank of 15 gallons. Then what you'd express this as a rate. So, in general, a rate would be like our miles to our gallons. So we would do like 300 miles over 15 gallons. That is considered a rate. Now, if we wanted to make it into a unit rate, though, we would need to simplify this into a 1. So what you're going to do is you're going to simplify the fraction by dividing both the top and bottom by 15. 300 divided by 15 gets you down to 20 miles. 15 gallons divided by 15 is 1 gallon. So what that means is for every 1 gallon, we can go 20 miles. So 20 miles per gallon is our unit rate. Finding unit rates can be helpful because then you can use that to answer other questions. For example, then they say, how far can you go with 40 gallons then? Well, if I know every 1 gallon gets me 20 miles, if I multiply this by 40, that will tell me how many miles I can go on 40 gallons. So I do my 20 miles times my 40 gallons, and it comes out to 800 miles. This concept of rates and unit rates can be used a lot also with maps and scales. So we have an example here where a map scale indicates that ½ inch on the map corresponds with 3 real miles. So on our map, every ½ inch is really 3 miles. How many miles apart then are two cities that are 2 1/4 inches apart on the map? So our rate here is going to be inches over miles. And this is where I was talking about saying you could set up a proportion. So a proportion is going to be where you're going to have two fractions, two ratios that are equivalent to each other. And that's kind of what we're going to have set up here. So we use our scale of where we know ½ inch is 3 miles. Again, we came from this ratio here, and now as a given information, ½ inch is 3 real miles. They tell us that on this map, these cities are 2 1/4 inches. So how many miles is that? So we set up our proportion here. We know that these two ratios will be equivalent, be equal. A common practice here for what people like to do is cross multiply and divide. So you're going to multiply diagonally both ways. 1/2 times x is 1/2 x. 3 times 2 1/4 is going to simplify down to 6 3/4. So I have 1/2 x equals 6 3/4. I'm wanting to solve for x though, not ½ x. So to cancel out the fraction, remember when you have a number in the denominator, you want to multiply top and bottom by that denominator. So we're going to multiply by 2 and by 2. 1/2 times 2 cancels out, leaves us with just x. 6 3/4 times 2 gives us 13.5 miles. With these units, with these scales and these units, we're going to use something called dimensional analysis, which is simply unit conversion. So maybe you have a unit rate in terms of 1 unit, but maybe they ask you a question in terms of another. Like maybe they give you something in terms of miles per hour, but they want to know something about feet per second. So you're going to have to do some unit conversions to get that. And we have an example here. A bicycle travels 15 miles per hour. How many feet will it cover in 20 seconds? So we need to convert this 15 miles per hour into a unit rate of so many feet per second, and then we're going to multiply that by our 20 seconds. So the easiest way I find to do dimensional analysis is to make one big conversion fraction. It gets a little messy, but to me it seems a little smoother than trying to do this conversion and then trying to do another one, and maybe sometimes you have to do a third one to finally get what you need. So what we're wanting to do here, we're wanting to convert miles into feet. So we're going to set up that conversion first. I have 15 miles over 1 hour. That is my rate. This is going to be my conversion. So when you're setting these up, whatever unit you're trying to cancel out, you need it in the opposite part of the fraction. So since miles is on the top here, I need miles on the bottom of my new fraction. That way they cancel each other out. I know that miles are the bigger unit, so 1 mile is equal to 5,280 feet. Again, that way when I do this now, miles on top, miles on bottom, they will cancel out. Now I'm wanting to convert hours into seconds. My hour is on the bottom here, so I know it needs to be on the top here. Hour is the bigger unit, so 1 hour is equivalent to 3,600 seconds. And if you don't know these unit conversions, you can, look up the conversions if you need to. But you can also just think, there's 60 seconds in a minute, 60 minutes in an hour, 60 times 60 is 3,600. So again, hours on top and bottom will cancel each other out. This is going to leave us with just feet and second. Those are the only 2 units left, which are the 2 we need. So what you're going to do, you're going to multiply straight across the top. 15 times 5,280 times 1 comes out to 79,200 feet, because that's my only unit that remains. Same thing along the bottom. 1 times 3,600 is 3,600 seconds. But that is a goofy and terrible looking fraction. 79,200 over 3,600. We want to make that into a unit rate. So we're going to divide top and bottom by that 3,600. 79,200 divided by 3,600 leaves us with 22 feet per 1 second. But we're not done, because they wanted to know how much in 20 seconds. So we're going to multiply this 22 feet by our 20 seconds, and we're going to have 440 feet in 20 seconds. All right, we got another example here. And this will be our last one. A 1,000-foot spool of bare 12-gauge copper wire weighs 19.8 pounds. How much will 18 inches of the wire weigh in ounces? Now, what they'll like to do on word problems is they'll like to give you extra information you don't need. For example, 12 gauge, doesn't matter. That's a useless number that's just there to throw you off. So, what I'm going to do is I am going to go more of an algebraic route of solving this. If you wanted to, you could have done it this way, but I wanted to show a different approach to this. So first off, we have feet and we're going to inches. So 1,000 feet to inches. There are 12 inches in 1 foot. So 1,000 times 12 is 12,000 inches. Now we're going 19.8 pounds to ounces. There are 16 ounces in 1 pound, so 19.8 times 16 gives you 316.8 ounces. All right. We are doing inches to ounces. That is our ratio here. So if you had gone about this, you would have gone down to this, or you would have gone to this part like we have here. You then could have converted it, if you wanted, down to a unit rate, but we didn't. I left this here like so because this time our unknown amount was on the bottom. So that's why I left it like that. Again, if you wanted to reduce this, you could have. There's nothing wrong with that. I just chose not to. So 12,000 inches over 316.8 ounces equals 18 inches over X amount of ounces. Again, you're going to cross multiply and divide. 12,000 times X is 12,000X. 316.8 times 18 is 5,702.4. This gives us this nice one-step equation here. Divide by 12,000 on both sides, and it comes out to x being 0.4752 ounces.